In this tutorial, we're going to look at the Mann-Whitney U test. The Mann-Whitney U test is a statistical test that can be used to see if there's a significant difference between groups. A Mann-Whitney U test is used when you have an independent measures design. This means that there are different participants in each group, i.e. you have separate groups. In order to carry out a Mann-Whitney U test, you also need to have ordinal data. Ordinal data is numerical data which can be put into an order. However, the differences between the numbers are meaningless or difficult to determine. For example, you might ask people to rate a therapy out of 10. This means their ratings can be ranked in order. But it is difficult to determine the difference between a person giving 9 out of 10 versus 8 out of 10. Let's look at an example of when we might use a Mann-Whitney U test. A researcher might ask two groups of schizophrenic patients receiving different therapies to rate their treatment out of 10. There are two conditions, with each participant taking part in only one of the conditions. So it is an independent measures design. The data are ratings, which is ordinal data, and so the Mann-Whitney U test is appropriate. If you look at the table, you can see there are two groups. Group A receiving therapy A and Group B receiving therapy B. In Group A, we have 6 participants and their rating for therapy A is given out of 10 in the next column. Then in the third column, you can see that Group B consists of 6 participants. And in the fourth column, you can see their rating out of 10 for therapy B. A Mann-Whitney U test requires all the scores to be ranked together, as if they came from one group. Look at Group A in the table. Notice how participant 3 and 5 in Group A both ranked therapy A as 2 out of 10. This is the lowest rating for both therapy A and therapy B. If participants have the same score, they are given the same rank in a Mann-Whitney U test. Now look at Group B. Notice how participant 4 in Group B has rated therapy B as 10 out of 10. This is the highest rating. This score needs to be given the highest rank out of the 12 scores altogether. We have 12 scores because there are 6 scores for therapy A and 6 scores for therapy B. Now let's try to rank the data. The Mann-Whitney U test requires all the scores to be ranked as if they came from one group. So let's put all the therapy ratings in order. 2, 2, 3, 4, 5, 5, 6, 6, 7, 8, 9 and 10. Notice that we have 2 participants who rated their therapy as 2 out of 10, and there's also 2 who rated their therapy 5 out of 10, and there's also 2 that rated their therapy 6 out of 10. When there are 2 of the same ratings, they have to have the same rank. The table on this slide shows all the therapy ratings in order. Now, if we look at the first 2 ratings, or the lowest ratings, which are 2 and 2, they would normally have the ranking 1 and 2, but because they're the same rating, we have to give them a number in the middle, which is 1.5 and 1.5. So their ranking is 1.5 and 1.5. Then the rating 3 out of 10 gets a rank of 3. The rating 4 gets a rank of 4. Then because we have 2 ratings that are 5s, they would normally hold the place 5 and 6 in the ranking order. But because they're both the same, we have to give them the same rank. So that ends up being 5.5 and 5.5. Then we have another 2 ratings at the same 6 and 6. They would hold the rank 7 and 8 if they were in order. but because they're the same ratings, they have to have the same rank, so they get 7.5 and 7.5 as their rank. Then the rating 7 ranks 9th. The rating of 8 out of 10 ranks 10th. The rating of 9 out of 10 ranks 11th. And the rating of 10 out of 10 ranks 12th. This table shows how the two different groups have been ranked together. We can see Group A and its ratings out of 10 and then its ranks. And then we've got Group B and its ratings out of 10 for the therapy and then its ranks. Here is the formula for the Mann-Whitney U test. I want to look at the bit at the end first. Do you know what the symbol sigma means? The symbol sigma means the sum of. So sigma RA is the sum of the ranks for Group A's data. And sigma RB is the sum of the ranks for Group B's data. Let's look at our data again. You need to add up the ranks for Group A and the ranks for Group B. Sigma RA is the sum of the ranks of Group A's data. And that's going to be 3 plus 4 plus 1.5 plus 7.5 plus 1.5 plus 5.5, which equals 23. Sigma RB is the sum of the ranks for Group B's data. So that is 11 plus 9 plus 5.5 plus 12 plus 7.5 plus 10, which equals 55. Let's look at the Mann-Whitney U formula again. The N in the formula relates to number of participants. NA is the number of participants in Group A, and NB is the number of participants in Group B. We already know that sigma RA is the sum of the ranks for Group A's data, and sigma RB is the sum of the ranks for Group B's data. So now we know what everything in the formula means, we can calculate UA and UB. So let's calculate UA. In step 1, we calculate sigma RA, which we already did, and that's 23. In step 2, we need to multiply the number of participants in Group A, which is NA, by the number of participants in Group B, which is NB. That's going to be 6 times 6 equals 36. Then, step 3, we need to calculate NA times NA plus 1. NA plus 1 is 6 plus 1, which equals 7. And then we need to do NA times NA plus 1, which equals 7 times 6, which equals 42. In step 4, we need to calculate NA times NA plus 1 divided by 2. So that's going to be 42 divided by 2 equals 21. Step 5, we calculate UA equals NA times NB plus NA times NA plus 1 divided by 2 minus sigma RA. And so as NA times NB equals 36 and NA times NA plus 1 divided by 2 equals 21, and sigma RA equals 23, UA is going to be 21 plus 36 minus 23 equals 34. Now let's calculate UB. Sigma RB is 11 plus 9 plus 5.5 plus 12 plus 7.5 plus 10 equals 55. You already know that NA times NB equals 36. You also already know that NB times NB plus 1 divided by 2 equals 21, as they are the same number of participants in Group B as in Group A. So UB equals NA times NB plus NB times NB plus 1 divided by 2 minus sigma RB, which is 36 plus 21 minus 55 equals 2. So what is the value of U? The final calculated value for the Mann-Whitney U test is the smaller of UA and UB. So as UB is the smallest value, UB is the value of U. Therefore, U equals 2. Once we have a calculated value for U, we need to compare it to a critical value. Critical values are numerical values which researchers use to determine whether or not their calculated value from a statistical test is significant. Psychologists prefer to use the significance level p is less than or equal to 0.05 to judge whether to accept a hypothesis or not, because it means that there's an equal or less than 5% probability that the results are due to chance. Therefore, you need to look at Mann-Whitney critical value tables for p is less than or equal to 0.05, the 5% significance level. So now we're going to look at this critical values table. We're going to look at N1 is 6 because we had 6 participants in group 1 or group A, and then we're also going to look at N2 is 6 because we had 6 participants in group B or group 2. And if we see down from N1 is 6 and N2 is 6, we can see that they cross over at the number 5, and this is the critical value. Notice that this is a critical values table for U values at the 5% significance level, or P is less than or equal to 0.05. So now we're going to compare the critical value with our calculated value of U. For Mann-Whitney U test, U has to be equal to or less than the critical value for the results to be significant. The critical value for a two-tailed test at 0.05 significance level equals 5. As U equals 2, our calculated value, and this is less than the critical value of U at the 0.05 significance level, this means that there is a significant difference between therapy A and therapy B.